Experiment number 3. Aim: to determine the equivalent resistance of two resistors when connected in parallel. Apparatus and materials required. Two given resistors, ammeter, voltmeter, rheostat, key, connecting wires, sandpaper, etc. Theory: when one end of each of the two resistors are connected at one point and their other ends are connected to another common point, it is called a parallel combination. Figure 1 shows resistors in parallel. The equivalent resistance Rp in parallel combination is given by 1 by Rp is equal to 1 by R1 plus 1 by R2. The total current flowing through the circuit is equal to the sum of currents passing through individual resistors. That is, I is equal to I1 plus I2. Equivalent resistance R with the base P in this case is always smaller than the smallest resistance of the given two resistors. Equivalent resistance of this combination of resistors can be found out by using Ohm's law as shown below. This is the circuit diagram for parallel combination, where A is the ammeter, K is the key, RH is rheostat, V is voltmeter, R1 and R2 are resistors. Figure 3 before you. Components layout for determination of equivalent resistance of a combination of two resistors in parallel. Procedure: note down the individual resistances R1 and R2 of the given two resistors. Connect R1, R2 in parallel and complete the circuit according to the circuit diagram as in Figure 2. Components layout for the experiment is given in Figure 3. Adjust the rheostat for a small current. Insert the key and note the reading of ammeter and voltmeter. Increase the current step by step with the help of rheostat and note down the different readings of A and V. Observations and calculations. Now, record all the observations in the following table and calculate the values. Result: the experimental value of equivalent resistance Rp of the parallel combination is equal to the calculated value within experimental error limits. Hence, the relation Rp is equal to R1 into R2 divided by R1 plus R2 for parallel combination is verified. Precautions: the connecting wires should be thick copper wires. The insulation of ends of connecting wires should be removed using the sandpaper. Connections should be tight, otherwise some external resistance may introduce in the circuit. The ammeter should be connected in series with the resistor such that the current enters at positive terminal and leaves at the negative terminal of the ammeter. Voltmeter should always be connected in parallel to resistor. The pointers of the ammeter and voltmeter should be at 0 mark when no current through the circuit. Current should be passed through the circuit for a short time while taking observations. Otherwise, current would cause unnecessary heating in the circuit, which may change the resistance of resistors.